Hello guys, welcome to introduction to macros. In this video, we're going to talk about what a macro is and how to use it, a different type of macros, and some pitfalls that you will have when using macros. Okay, so conventional wisdom believes that using macro is not a good practice. So if it's possible and there are alternatives, we would oftentimes not use macro. Okay, so but one thing I do see that in Unreal Engine is that you see a lot of macros being used above almost I think more than half of the functions does have the macro above them. Sometimes, especially when you're creating something that is blueprint compatible with a lot of variables you want it to be able to alter or read from blueprint, that's when you see the macro on top of the function or the variable. So in that case, I think it is important that we understand what macro is, so that when we encounter that, we're able to understand what it does and use it properly. So a macro is basically something you define with the define preprocessor. So define something, and you define it with an identifier. So you can call it whatever. In this case, maybe I can say pi, and then I can give it the actual value of the pi. There is no equal, just the identifier and then space and then the body of this macro. In this case, I'm going to say 3.14. Okay, and this is basically how you create a macro. And this macro is basically the value of pi. So when I want to use it, I can say, actually, I need to have the L stream to do that. L stream. So if I wanted to calculate the circumference, C will be equals to pi times the radius. So maybe I can create a float radius equals to, I don't know, 10. And then what we have is going to be times the radius times 2, and then that's it. Right. So this, when you compile, is going to give you the calculation to the actual circumference. And what's actually happening when you use macro is that before actual compilation of the file, it's going to try to replace this identifier, this pi macro, by its actual body, which is in this case 3.14. Okay, so that's what's happening before compilation. It's going to go pre-process it and then replace pi with 3.14 every time when it sees pi in your code. Okay, all right. So one thing you do notice that one thing that's not recommended by any programming book is that to use this kind of like a value, right? This kind of value like 3.14 directly inside of the code that actually needs to have a meaning. It's going to be hard to debug. And because of that particular reason, the preprocessor replaced the pi with 3.14, right? That's actually doing that bad practice already. And not even mentioning that when it comes to something like when you have to debug and you wanted to be able to see, you know, different pointers and where are they in the memory. And this one does have any memory or anything like that. It's basically a text that's getting replaced. So there's no memory location or anything related to that. So it's going to be magical and you don't know what that is. And generally speaking, when you're using macro, it is not very easy to debug because it gives you mysterious debugging errors. Anyway, so we could actually already use a different method to do this. If you wanted to use a variable called pi, we can do a constant float pi equals to 3.14, right? And that will do the job nicely, so that we don't have to worry about having to say having a anonymous variable or value already. So in that case, we would prefer to use this, or maybe even a static function to get a static value called pi, which is 3.14. things like that, instead of using macros. And macros can be also dangerous because that token, right? If you do this, it's gonna give you an error because, again, before compilation, what would happen is the preprocessor will actually basically replacing the PI with 3.14 because that's what's happening. And you could imagine that what's going to happen is that the actual file, when it compiles, is going to be like this. And of course, this is going to be a wrong syntax. And that's why you're getting errors. So it's also taking over variable names. And you got, let's see what kind of error are we getting. Let's compile this. Okay, you can see you got this weird arrow, which is syntax error constant. And when you have that as pi, let's see if it's giving you the same arrow. Maybe it would give you a different arrow because the compilers here are really good. Nope, it's still gonna give you this weird arrow called constant. Well, if this is in another header, this is really confusing because you are sure that this is a correct syntax, right? If this line never exists, then this could have been a correct syntax, right? And it's gonna compile and no problem with that. Okay, but if you have this weird macro there and you're using the same name by any accident, and then the arrow will be like, like this, like syntax error constant, and how do you even know what this is, right? This is really bad. So if this was another like constant float that's already defined, then it's going to give you an error which says there is an redefinition, right? So it's easier to see, okay, that it's multiple initialization or redefinition, right? So that's a debuggable error. And with that macro, it's not going to be that easy. So that's why even for the standpoint of debugging, this is not a good practice to use macro all the time. All right, so that's basically what a macro is. And let's talk about some variant of macro. All right, so the macro we were using earlier is going to be a object macro. Okay, so what it feels like is an variable basically, but you can also define a macro that looks like a function. So we can say define function like let's try to get the smaller number, so we can do a min and then parentheses, and then we can say x and y, right? And then we can get the result of x bigger than y or smaller than y in this case, right? And x or y. So this will give you, not give you, but will and this will evaluate to either x or y based on which one is smaller. Okay. So I can say int c equals to min 2 or 5. So it's going to give you the smaller one basically. And because you're replacing basically this min with that, and this one doesn't have a semicolon on the back, that's when you have to have a semicolon on the back also here. And then we can compile it, and we are getting have to actually print that out. So let me do that real quick. And then, all right, and then we're getting 2, right? And if we change that to 6, then we'll be able to get 5 because 5 is the smaller one. All right, you can see we're getting 5. So this is more like a function now, but it is actually a macro, and what's happening again is going to be replacing this guy with the actual content here. So, but it's using arguments. So instead of this, it's going to do basically 6 smaller than 5, right? And 6 or 5. And that's what that is. Okay, so that's basically how you can do like a function type. All right, let's just take a look at another example of the macro functions. So I'm gonna go define a macro that combines 2 text. So I'm gonna call this guy combine text. And by the way, conventional ways of doing macro is using all uppercase and then underscore for dividing the words. Okay, and then I'm gonna combine text A maybe B. Okay, in this case, if you ever wanted to create multiple lines for this function, you can actually use the slash to indicate that there are more lines underneath, and that all belongs to the same macro. So now what I can do is just A plus B, and that's it. So now this A plus B is actually part of the macro. Okay. So in order to combine text, I need to have the data type of the string. So I'm going to include string here in C++. And then I'm going to say cd string, cd string A will be equals to hello, hello, and then another string B equals to word. Okay, and then if we want to print hello world, we can do this. Maybe I need to have a space here in the middle. All right, so what we can do is std cout and then A plus B by using combine text, then A and B. Okay. And then we're basically combining A and B together, and let's run this. You can see we're getting hello world. Probably need to also have the exclamation mark. All right, cool. So that's how you create multiple lines. You can keep adding new lines if you wanted to. If you want to have more stuff, okay, so you can keep on doing this and do whatever. All right. So this is a macro function, but we can do a function that does the same thing. So if we were doing the same function, same thing using function, we can do this. So std string, right? And then we can say combine text, and then we can say constant std string, and then A, and then same thing B, and then we can basically return A plus B, right? Now this is using an actual function to do this. Okay, so we can do the same thing using our function now with A and B. We would get the same result, hello world, but there is again a different, and oftentimes, if it's possible, I still would recommend to use the function. Now, the reason for that is because when you're doing this combine text with the function, it does have a very clear signature. So you know that it does require two strings, and because it's marked as constant, you're confident that it's not gonna change the value of your variable. And you know that it's passing by reference, so everything is really clear, and you also know what it does eventually when it evaluates, right? You know what the return is. Okay, so there's no accident when you use function. You know exactly what's going to happen. But when you're using the macro, then it becomes vague, so you don't even know what's going to happen. You don't even know what's going to be eventually B, right? Eventually when you evaluate it. So it can even do this. You can combine text, but you can combine values like 1 and 2. And it's not do that, and there's no arrow of it either. You can get the value of 3, right? So even you're passing the wrong thing and it not doing what it intended to do, sometimes it's gonna be okay, and it's gonna cause this kind of like a weird logical error that you never will be able to find quickly. So again, a downside of using macro. So let's take a look at this very interesting example of macro. So what we're doing here is we define a macro to get the smaller value between x and y, and we're using it in our main function, and we're using it twice, and one is inside of another one. So if we try to see what's going to happen, or try to predict what's going to happen, we would assume that we're going to get the smallest value between 4, 5, and 3. After all, this mean will be 4, right? And then the smaller one between 4 and 3 eventually will be 3. And let's take a look at what we're getting by compile and run this. But surprisingly, we're getting the value of 4. Okay, So that doesn't look right. Okay, so again, one thing you do always have to be aware of is that strictly speaking, macro is not a function and it's only going to do its replacing job. So if we really want to evaluate this thing ourselves, it will be like this. So I'm going to say int macro eval be equals to, first of all, we do the replacement. We can evaluate either one first. So we can say, we can evaluate the outer first min and then 4 and 5, right? And then we're going to do smaller than 3, right? And then that, and then we're going to get this or 3, right? That's what's going to happen when you expand this guy. When you expand this guy, you got basically this, right? And then you keep expanding this. So I'm gonna keep on doing that. So I know that this one will be eventually becomes the or will be replaced with 4 smaller than 5, right? And then 4 5. So that's exactly what's gonna happen. This is gonna be replaced with that, and also here. Okay, so eventually you're evaluating this nonsense here. All right, so of course this is not going to be the equivalent of getting the smaller one between 4 and 5 and you getting the smaller one of 3. There is a order to go through this, and I don't think anyone will have any comfortable like sense of solving this. This will be a headache to solve it, and because of that particular reason, macro is dangerous, and we wanted to use it in this kind of way. We do this, sometimes with functions, and it will be fun, right? The function would just behave exactly like what we would expect. But again, the macro is not a function. It's basically a replacing mechanic. So after replacing, it can be anything that we cannot really predict. So this is what we're getting eventually. So let's actually get this one also printed out, and you will see again after the evaluation it's going to be 4. So this is totally a valid expression. The result is, however, not what we really want to do or to have. Okay, so that's one thing to be always aware of. So with that being said, one thing that we can do to make it work is that we can add parentheses around the macro body. That's going to basically force it to evaluate the result of this first before connecting it to another. So what's going to be like in here is going to be like we add parentheses like this, so that we're evaluating the internals of the first macro first before moving on to the next. And that should give us the correct results. So if we do compile and run it, you can see now we're getting the value of 3, right? So it doesn't mean we cannot make it work. And so that just means you have to be really safe, and you want to get the best results, and you have to, and no errors at all, you have to add parentheses like this, because x and y could be a different expression, right? And because of the replacing nature, it's not going to guarantee it's going to evaluate x first. So this is actually this is actually the only way you can make sure that it's going to work in any cases. So that, as you can see, it actually becomes a little bit more complicated than the actual function you can define. So you can say int min will be x and y, right? And then you can just do return x smaller than y, x and y, right? You can see the different here. Oh, actually we have to say int and int here, right? So the function is much easier to read in this case. All right, anyway, so one thing to be aware of. So let's talk about some details that we could have encountered. here, let's say when you're using macro, it follows the same rule as the function when it comes to reading identifiers, so that if you put quotation mark in here, then this y will not be evaluated to the value of y, but just the character y. Okay. One thing that is interesting that the macro doesn't really care. So if even you compile this without using the macro, it's gonna be fine. It's not gonna complain anything. Okay. So that's one thing to be aware of. When you have syntax error in macro, it's not gonna complain about it sometimes. All right. All right, let's take a look at another example that we can do with macro by using some special preprocessing operators. So I'm gonna define a function called warn if false. Okay, and then when I pass in the boolean, I'm gonna call this guy b instead of ax or something. We can call this whatever. So maybe to be more specific, bool argument. All right, and then I'm gonna do multiple lines. I'm gonna do a slash here. Okay, so I'm gonna say if bool not bool argument. Okay, then we're gonna do a warning here. I'm gonna say std cout, and then I'm gonna say hashtag bool argument, and then is, and then false. Actually, just false. All right. And because it's multiple lines, we need to add a slash at the end of all the lines, except the last line. So I will just do that on the very end when I'm done with my coding. Sometimes people have all these slashes pushed to the very back of all the lines, so that way it's not that distracting, and the preprocessor will ignore all the spaces you have. All right. So this is a macro that's just gonna basically print out something if the boolean is false. But one thing you do see that is very unique here is that we have this hashtag and then the name or the identifier of the argument. Okay, this preprocessing operator is basically saying that I don't want the value of this guy. However, I do want whatever that is put in here, whatever literal that is in here. So now if we do this, I'm going to say, maybe I can create a bool, door is open. Okay, and it's equals to false. Okay, and the if should evaluate to true, and then we can do this, warn if false, and then b door is open. All right. So let's try what's gonna happen. And you can see what's gonna happen is that it's using the actual literal or the identifier of the boolean here we passed in here, right? And then it's gonna print out false because we did that here. All right. As you can see, this particular preprocessing operator can be useful sometimes. We wanted to do some warning, especially. And we want to really print out the name, the identifier of the variable instead of the value, and that's how you do it. Let's take a look at another example of this hashtag operator. I'm gonna do a simple macro function, define string, which will convert the argument as into a string literal. Okay, so this is basically going to put whatever in, it's going to convert whatever that is here into a string. So we can see out that. So std cout, and then we can do string, we can do anything like blah, for example, and then that should be enough. So if I run this now, I would have blah printed out. Okay. Now if I do blah space blah, okay, you would expect this could give you an arrow, but it's not. It's gonna actually just print out blah blah. Okay. And if you were having a lot of spaces in the middle, however, when it's getting processed, it's gonna ignore all the spaces except one. So if there are multiple spaces, they'll be recognized as just one space. Okay. And also, if you have a lot of spaces in front or after all the characters, and those spaces will be all ignored. Okay, so any space before or after will not be taken into consideration. Okay, so that's something to be aware of. Now, what if we put in a macro here in the middle? Let's take a look at that. So if I go ahead and define again our pi as 3.14, and then we use that here. Now, generally, again, we will expect that the pi will be replaced with 3.14. So when we run it, we should get 3.14 printed, but what we're getting is actually just pi. Okay. The reason is because when the macro is getting evaluated, it's gonna do scans to figure out if there are other identifiable macros and then pre-expand them before evaluating. But there is an exception if whatever the argument is actually being used with this hashtag, then that means you're trying to convert it into a string. And when that happens, it's actually not going to do anything to this argument, even it is a noticeable or recognizable macro. So that's why it's not gonna expand it. It's just gonna say whatever this is, convert it into a string. But there is a workaround to make this actually work. So we can actually do another one that doesn't really involve the hashtag operator here. So we can do a dip string, okay, with s, and then we just call this the macro we created earlier. Now notice that this one does not have hashtag s in the body, right? And because of this particular nature, it's gonna try to expand the macro if there is any. So if I call deep string with the pi argument and run it, it's gonna actually print out 3.14 again, because this one it's not involve having the hashtag in the body, right? Because there's no hashtag in the body that uses this argument. The preprocessor will actually try to evaluate, or what I say was expand, right, to get the actual body it does represent, replace the values, and then keep on using it, and then that's when it reaches here, and that's when we got this guy printed like that. Okay, so something that is really interesting in the preprocessor, and they call this again the pre-scan of the argument. Another example or another operator we can introduce here now is using two hashtags. Okay, so when you're using two hashtags, it requires one on the left and another one on the right of those two hashtags. So let me do this A and B stuff, and I can change the name of the macro into combine, and then it's gonna do A hashtag B. Okay, so what this does is basically gluing those two arguments together into a longer argument or identifier or literal, whatever you want to call it. So let me try this. Std string std cout. And then when I see out the combined result, of A and B, and for A and B, I'm going to try to do two strings, hello, and then word. All right. So now if I run this, I'll get hello word. Okay, what it does is basically combining A and B, or basically replacing this hashtag with A and this hashtag with B, and then you're getting the final result. Okay, so gluing things together is what it does. We can also try some other different variables like 1 and 2. Now, what's really interesting is that it's not going to be 3, it's actually going to be 12 because it's 1 and then 2. So it's a simple operation. It's not going to be using add, but rather just put those two together and use it in whatever way that the other part of the program will have to use it. Okay, all right. So we can also try to plus 3. Let's see what this does. And I would expect to see 15 because it's 12 plus 15. Okay. Oops, let me close that and rerun this. And we'll be right because that's that's exactly what's happening. Again, when you're thinking about this, never think about this in a function way, and never think of it as a typed stuff. It's just gonna be a literal being replaced with something else after evaluating or expanding the macro. All right, another example of function like macros is a macro function that takes a flexible amount of arguments. So let me define one like this. I'm just gonna call this flexible arguments, and then we're gonna take flexible amount of arguments. To do that, you can just type in 3 dots, and what it does is gonna be using this particular identifier or literal like 2 underscore VA all uppercase, 1 underscore and ARGS as arguments, and then 2 more underscore. This one will be then representing whatever you put in as the 3 dots, basically a flexible amount of argument. Okay, let's take a look at what we can take a look at it by printing it out. So I'm gonna see out flexible argument, and then I can type in 1, 2, 3, 4, and let's take a look at what's gonna happen if we run this. You can see now we're printing out 1. Okay, that's not because it's only taking 1, but rather it's when you actually hover the cursor here, you can see it does expand to 1, 2, 3, 4, right? So basically before compilation, this will be replaced by this, and this is gonna be whatever in here, and this is gonna be in this case 1, 2, 3, 4 with comma in between them. So this is gonna be 1, 2, 3, 4 when it compiles after the replacement of the macro. So now if I run this, you can see what we're getting 1 exactly. So that's just how C++ does this when you have multiple values with comma here in the middle. Okay, so with that being said, again, this is just going to be replacing what you have in here. How do you use it is all up to you. And you could convert this into a list of literals or strings or int, or you can pass this along to another function that takes also flexible amount of argument, right? So it's all possible for you to do whatever you want to do with it. But again, all you have to know when you see this argument, when you see this type of macros, you know that this represent whatever that is into these dots. And you could also have another argument as named argument, okay, and it's going to be fun. So what you can, let me actually create a multiple line, and we can say can do this, right? And maybe we can do something with A if we wanted to do that. I can have another line maybe, or maybe this A and then that, and then maybe even a end line. Okay, just to be able to have the simplest possible result. And let's try this, and then we can say flexible arguments. And then we can say 1 and then 2, and then that's it. Let's see what we have. Actually, we don't have to have the semicolon because it's in there. And you can see we're printing out 2 and 1. 2 because this one goes first, right? and then 1 is going to be A, which is going to be, you know, this argument here, and that's going to be the second, and that's what we're getting 2 and 1. Okay. All right. So yeah, I think that's what that is. We can even, I think we can also just do this just to combine things we have learned together. And then when we do this, we're going to print out 21 again, but this time it's going to be 21 as an integer, so we could actually plus 3 again, and we're going to get 24 afterwards, as you can see here, right? So yeah, this is kind of like interesting things. Again, what's going to happen is going to be using this guy to replace this guy with whatever in here, and that's how there is. All right, let's talk about multiple definition and undefining. Say we have defined this here, and let me define it one more time with the same signature, but different body, and see what happens. So I'm going to do also A and then that, but this time maybe what I do is basically just VA argument without anything. Okay, now if we run this, you can see we got a warning, which is read definition, but it's actually still going to be able to run and to compile. And what the compiler or the pre-processing choose to do is using the second definition we gave it, or the newest definition down the line. So that's why we're getting the value of 5, because it's going to use this guy, which is the second one, in this case 2, and 2 plus 3 equals 5. So this, if I have the cursor here, you can see it expands to 2. Okay, now with this without this definition, you got the value expanded to 21. Okay, you can see the difference here. So you can define a macro again and again. You will get warnings, but the compiler is okay with it, and it's going to use the newest definition. All right. To avoid the warning, you can undefine something. So I can do hashtag undefine. Let's actually do that inside of the main function. So undefine, okay, and then we can undefine our flexible argument, same signature, so on and so forth. Okay, so now it's undefined, and when you undefine something, it becomes something invalid. So if you try to basically do something with it again after it's undefined, you get error which says identifier this is not defined. Okay, as you will see here. All right, so after undefining, then you can define it again. So you can say I'm going to define our flexible argument one more time, but this time we're going to just use again just the argument, and then we use it again here. We've got 2 different results. One is using the previous definition, and then after undefined and define it again, and we use it again, we're gonna get the second definition here. Let's try this. Okay. Oops, let me close that. Try this again. You can see we're gonna 24 and then 5. The first 24 is gonna be the first result, and then after undefined and define again, we're getting 5 because this now expands to 2, not like this one expands to 21. So it's the same function call with the same argument, but we're getting 2 different results because we actually do undefine it. All right, so that's going to be define and undefined. Right, so this should conclude the necessary things you need to know to understand macros. But the bottom line is, as you can already see in the examples before, even we're not doing anything complicated, it already becomes something that's messy and hard to manage and problematic sometimes. The result is hard to predict, and it doesn't really respect to a strict syntax. All right, so one of the extensive usage of macro is actually inside of Unreal Engine. So let's take a look at that. So this is a typical code. This is the character class of Unreal Engine, and you can see above many of those member variables, you're seeing a macro above it. Okay, so as you know, that macro will basically replacing with something else, so it's not actually doing anything to what's underneath it. If you go to this U property and Control G to go there, actually just jump to the definition of there. I'm using a plugin, so I can just use the shortcut to go there. And you can see the definition of this U property is gonna be this. It's defining a macro that takes a flexible amount of argument, and its body is empty. So because of this nature, what's gonna happen before compilation and after processing, pre-processing, the actual code in here will be exactly like nothing, like this, right? When it compiles with C++ compiler, because you know that when you see the definition, you know that it's empty, right? So why is this useful? Because in the comment they're saying that this macro is basically wrapping the metadata that they want to use by this Unreal header tool, which is something they will actually run through the code before compilation. Right. So this is basically collecting data. It's not replacing anything or using macro to do something specific, but rather using macro to remember some information that the user wants to specify. Right. So this is a clever use of macro. All right. But that's not everything. Everything inside of Unreal does when it comes to macro. So you take a look at this. I think a good example of a macro usage will be delegates. So one thing we can take a look at is the, let me see if you can find it real quick. Maybe this camera bone thing. And for every primitive component, we have this on-component begin overlap thing. Oops. Let me get it. Component begin overlap. Okay. Now this one is a F on component begin overlap signature, and if you go to the definition of it, you can see it is defined by this macro. We know that is a macro is because it's using a weird syntax already. It's using comma between the type and then the argument name. So if you take a look at the definition of this macro, you can see it's defined as this, and it's incredibly long. And when I see this, I don't have any energy to actually try to decipher what's going on internally. And all I wanted to do is just use it as they say how to use it. And I don't want to go through the troubles of trying to investigate and see what's going on, just because the macro again is something ugly, and I do think that there's a reason to use it, but I honestly don't know the reason. Okay, maybe it's for performance, maybe it's for organization. So that I think macro has its places when it comes to complicated programming. Like Unreal is like millions of lines of code, so maybe to manage it, they do have to use macro to simplify some of the process, or it's for performance that I cannot really say because I don't know how it works. But yeah, you can see this macro is actually also invoking other macros. So there is a nesting macros, which macro is not very good on doing this. It will cause trouble sometimes when you have macro calling another macro, as we have seen before already. So yeah, I still recommend to not use macro, but that doesn't mean that macro will not appear in the code you'll be working on. Especially here, like you can see, Unreal has so many of those things. All right, anyway, so if you're interested, you can try to decipher this to have a better understanding of macro. Just see what's going on here, and maybe you will be able to understand it. But again, Unreal Engine is like a rabbit hole all the time. it's oftentimes a whole day of investigation, if not more, to see how everything works with just one line of code internally. All right, so yeah, that's gonna be it for Macros. Thanks for watching. See you next time.